Hi, good afternoon, and welcome to the Facade Engineering and Management course. Today I'm going to introduce to you the facade engineering, what it's all about, its significance to the overall building performance, and the role of facade engineers in the building construction industry. So, without further ado, let's get started. So, let's first define what is facade engineering. So basically, facade engineering refers to specialized discipline that focuses on building facades design, analysis, production, and construction, highlighting the key aspect and scope of facade engineering as a distinct field of expertise within the construction industry. So it involves the application of engineering principles to create a high performance, visually appealing, and environmentally responsive building envelopes. Facade engineering encompasses a range of technical and aesthetic consideration to ensure successful development of building facades. So first is the design, of course. So facade engineering involves the creative and functional design of building facades. This includes considering factors such as architecture intent, uh, aesthetics, materials, the textures of materials, colors of materials, the structural performance, energy efficiency, and of course the sustainability. So facade engineers needs to collaborate with the architects and other stakeholders, engineers, to develop the design that meets the project requirements, performance, visions, and the functions of the facade. The next thing about facade is that facade engineers, the other responsibility of a facade engineer is to conduct various analysis to evaluate the performance of the proposed facade design, of course. And of course they are using a specialized software and tools to assess factors such as structural integrity, thermal performance, wind resistance, acoustic properties, and natural lighting. So this analysis helps to optimize the facade performance and to ensure that it meets with the regulatory and industry standard and compliance. The next thing that the facade engineers do is that it involves the production phases. So where engineers work closely with manufacturers and fabricators to translate the design into an actual building components like mullions, transom, brackets, glass, infills, different infills. So facade engineers specify materials, finishes, then assembly techniques, methods, and review the quality standards to ensure that the facade elements are manufactured accurately and meet the desired performance and aesthetic requirements. The last thing about facade engineering is that they are involved in constructions. So basically, facade engineers plays a vital role during the construction phase of the facade elements. So they provide technical expertise and oversights to ensure the successful installation of the facade components. So they work with contractors and construction teams to coordinate the delivery, assembly, and installation of the facade elements while adhering to the design intents, of course, and maintaining quality control. So all in all, facade engineering is a specialized discipline that encompasses the design, analysis, production, and construction of building facades. So it combines technical knowledge, creativity, and collaboration to achieve facades that are visually appealing, structurally sound, energy efficient, and meet the specific project requirements. So basically, facade engineers should work closely with other architects, manufacturers, and construction teams to bring this facade to life by contributing to the overall success of the building projects. The next thing is about the components of the building facade. So the building facades includes all the external elements that enclose and protect the building's interior spaces. It provides an enclosure, a protection, and aesthetic character to the structures. So it comprises components such as exterior walls, windows, doors, cladding system, curtain walls, shading devices, and other architectural features, and by minimizing energy consumption, utilizing renewable energy, renewable resources, and enhance indoor environmental quality. So technically, facade serves as the interfaces between the interior of an exterior environment, and it plays several important functions. So for instance, the building facade act as a physical barrier that encloses the interior spaces, separating them from the external environment. So it helps define the boundaries of the building and provides a controlled and secured environment for occupants. So the facade prevents the intrusion of unwanted elements such as weather elements, noise, dust, pollutants, contributing to the comfort and well-being of the building occupants. The facade serves as protective shields against various external forces. So it helps to resist winds, seismic forces, and other structural loads. The facade system is designed to withstand these forces and transfer them safely to the building's structural framework to ensure the overall stability and integrity of the structures. The facade also plays a critical role in regulating heat transfer between the interior and exterior environment, and it helps control solar heat gain, insulations and ventilation, influencing the building energy efficiency like air conditioning and thermal comfort as well. So a properly designed facade incorporates insulation. This is kind of the elements that we are considering when we are designing the facade to ensure thermal comfort inside the building. So we have to install the insulation materials, shading devices, glazing system of course, and ventilation strategies to optimize the energy performance and to reduce reliance to mechanical heating like air conditionings and cooling system. So the facade is visible, basically. It's a visible face of the building, like what we have on the screen. And it contributes significantly to the architectural character and identity of the building. It represents the building design intent and often serve as a statement of the building purpose or brand. So it's very important for the facade designer to consider factors such as selecting materials, colors, textures, proportions, and detailing to create an aesthetically and harmoniously exterior cladding that to enhance the overall visual appearance of the building. And of course, facade as one of the components, we have to consider the functionality and access of the facade. We have to incorporate some functional elements such as windows, doors, entrances, and other access points. So these elements provide natural lighting, ventilations, and controlled access for occupants. So the placement and design of these features like doors and windows shall be carefully considered to optimize the functionality, accessibility, and user experience of the occupants. So basically, the building facade is more than just an external appearance of a structure. So it encompasses all the external elements that enclose and protect the building's interior spaces. So the facade provides enclosure, protection, thermal performance, aesthetic, and functionality working in harmony to create a safe, comfortable, and visually appealing environment for the building occupants. So, what is the role of facade engineer? So, facade engineers ensures that the building envelopes blend harmoniously with the architectural design, enhancing its visual appeal and emphasize the importance of facade engineering in achieving a cohesive and aesthetically pleasing building exterior. So basically, facade engineering focuses on various aspects to ensure that the facade seamlessly integrate with the overall architectural design to enhance this the envelope of the building. So let us elaborate these things to which to see which factor are involved in this aesthetic integration. So we have to consider the design coordination with the architect to align the facade design with the overall architectural concept, of course. So we have to select the materials to see the appropriate materials that align with the architectural design, and to consider also the durability, sustainability, and performance of that material, and to see how different materials interact with lights and shadows and surrounding environment, for instance. So choosing the right materials for the facade engineers contributes to the ability to blend to blend the design with the materials that we just choose to the architectural design. And of course, facade engineers should pay carefully on the detailing and finishes, of course, of the building envelope. And like, for example, for the fenestration, ornamentation, and cladding system, and definitely for the interfaces and facade and transition, that they are seamlessly integrated into the overall design of the facade. So precise detailing and craftsmanship is very essential to create a cohesive facade to enhance the aesthetic of the building. So, so overall, the facade engineering ensures the building envelopes blends with the environment and the architectural design by choosing, a material that is very useful to select and harmoniously align with the visual design and appeal of the building. Next is the energy performance. So it's not only about the colors, the materials, the textures, and the visual aesthetic or integration of that with the surrounding and harmoniously with the architecture design to enhance the visual appeal. It also, the facade should also perform to optimize energy efficiency, thermal comfort, and natural lighting within the building. So it is so because it's placed to improve the environmental performance of the building, the energy efficiency, like a facade should have because facade has a direct impact on the building energy consumptions because it encloses the building. So through a careful design and material selections, a facade engineer can help to optimize energy efficiency. So for example, a high performance insulation material and glazing system like what we have on the screen can reduce the heat transfer between the interior and exterior, minimizing the need for heating or cooling system of the building. So facade engineers consider these factors such as solar heat gains, shading devices, and passive design principles to mitigate energy loss and improve the overall energy performance of the building. Because facade contributes to maintain a comfortable indoor environment, so by regulating heat gain or heat loss and thermal insulation. So therefore, a well-designed facade provides effective insulation against external temperature fluctuation and ensuring that stable indoor temperature and reducing the needs for mechanical heating or cooling. Another thing is facade should should be designed to reduce the reliance on artificial lighting during daytime. So therefore, a facade engineer should consider placement of the design of windows, glazing system, and shading devices to maximize daylight penetration while minimizing the glare and heat gain. So by optimizing natural lighting, facade can create a visually pleasing and productive indoor environment while reducing energy consumption associated with artificial lighting. And so therefore, we can contribute to the overall sustainability of the building. So by incorporating sustainable design principles such as the use of environmental friendly materials, renewable energy system, and rainwater harvesting techniques, for example, facade can minimize the building environmental impact. So therefore, the facade engineer should embrace sustainability strategies to achieve certifications such as LEED, BREEAM, or another sustainability organization to ensure that the facade design align with sustainable building practices. Facade also plays to maintain healthy indoor air quality. So by integrating appropriate ventilation system, a facade engineer can ensure the proper air exchange to minimize the buildup of pollutants and promoting a healthier indoor environment. So an adequate air filtration as part of the facade design can further enhance the indoor air quality and occupants' well-being. Next is the structural integrity. A facade engineer ensures the building envelope withstand various loads and environmental forces while providing structural stability. So, facade engineers employs their expertise to design and implement solutions that can withstand different types of loads and environmental forces. So, so the facade engineer should design the facade envelope, the building envelope, including with to withstand the various loads, including the gravity loads, wind loads, seismic forces, and other dynamic loads. So therefore, the facade engineer should analyze and calculate the structural capacity of the facade components to ensure they can safely support these loads and maintain structural integrity, and consider so they have to consider the material strength, connections, and load transfer mechanism to provide a stable facade system. Wind resistance. The facades are exposed to wind forces, which can exert significant pressure on the building envelope. Facade engineer incorporates wind load analysis and wind tunnel testing to assess the performance of the facade under different wind conditions. So the facade engineer should design the facade elements to resist wind pressure, mitigate wind-induced vibration, and prevent excessive deflections of the glass panel or any other elements or to that resulting damages, and to ensure that the facade's ability to withstand these forces because it contributes to the overall structural stability and safety of the building. Another structural factor that needs to be considered in building facade is the seismic performance of the facade. So in some seismic prone region, a facade engineer shall take into account the potential impact of earthquake. Engineers shall analyze the building responses to seismic forces and design the facade system to withstand the ground motion and maintain its integrity during seismic events. So this involves selecting appropriate material, designing connections, and considering flexible or ductile design strategies to accommodate building movements and to ensure that the facade is stable and safe. Another thing that needs to be considered in the structural design is the impact resistance of the facade. There would be some potential impact loads from sources like debris, accident, birds, or migratory birds, or extreme weather events like a storm or typhoon. And so therefore the engineer assessed the facade's ability to resist these impact forces and to incorporate protective measures such as impact resistant glazing, for example, or reinforced cladding system to mitigate damages and maintain the envelope's structural stability. Last thing is the environmental forces. What are these? These are various environmental forces that affect the building envelopes. It includes the temperature fluctuation, moistures, and ultraviolet radiation. So therefore the engineer should consider this factor on the facade materials and design, and appropriately includes protective measures to ensure durability, long-term durability, and structural ability. This may involve incorporating insulation, for example, or moisture barriers, UV resistant coating, or a weatherproofing system to protect the facade components. Next thing is the building functionality. So facade contributes to occupants' comfort by controlling heat gain, loss, noise transmission, ventilation, and moisture infiltration. So each of these aspects contribute to create a comfortable and healthy indoor environment. So as a facade engineer, we have to consider the heat gain and loss control, because facade acts as a thermal barrier to regulate the transfer of heat between the interior and exterior, or vice versa. So through the use of insulation material like energy efficient glazing system and a well-designed facade assemblies, a facade engineer could help to minimize the heat gain during hot weather and heat loss during colder periods. So by controlling the heat transfer, facade contributes to maintaining comfortable and consistent indoor temperature. Another thing is the transmission of noise. So reductions of this noise, mitigating the transmissions of external noise into the interior spaces, so to create a quieter and more peaceful environment inside. So a facade engineer shall employ sound insulation techniques such as acoustic glazing, sound absorbing materials, and appropriate sealing to minimize noise infiltration. So by reducing the impact of external noise sources such as traffic, construction, or urban sound, facade contributes to a more relaxing and comfortable indoor atmosphere. Another thing is the ventilation optimization. So a facade should optimize the ventilations and to ensure that there's a fresh and healthy indoor environment. So by considering a placement of windows, where they're gonna put the windows, vents, and air intake system to facilitate natural airflows and proper ventilation. So we should allow the exchange of fresh air and removing stale air. Because the facade contributes to improve indoor air quality. So by reducing the accumulations of pollutants indoors, the odors and humidity inside the building. So this promotes a healthier and more comfortable living of working environment for occupants. The last thing is the moisture infiltrations, which we cannot avoid that. So facades is responsible in managing moisture infiltration from the external environment. So it happens due to the change of temperature from outside to inside. So there is some moisture sometimes happening which is inside the facade. So facade engineers should employ various strategies, for example, so including a moisture barrier, weatherproofing membranes, and appropriate sealing to prevent water penetration into the building envelope. So by effectively managing this moisture, facade help prevent issues such as mold growths, dampness, and degradations of building materials. So this will ensure a dry and comfortable indoors environment to reduce the risk of because if you have molds inside the building, it will increase the risk of respiratory problems and also, of course, the structural integrity of the building. Last thing is the safety and security. No, not the last thing. I could say the last before the last thing, because we have another one which is sustainability. So the next thing is about safety and security. So facades should be designed to meet the safety standards, including fire resistance and protection against extreme weather events and impact resistance. So a facade engineer should incorporate measures and materials to ensure the ability of the facade to withstand potential hazard and to protect the building and also its occupants. About the fire resistance, so a facade engineer addresses the fire safety requirement of the building facades. So fire resistant materials and systems such as fire rated cladding, non-combustible insulations, and fire resistant glazing shall incorporated into the facade design. And these materials help to prevent a rapid spread of fire and reduce the risk of fire-related hazards. Facades are designed to meet specific fire safety standards and regulations, and to ensure the safety of occupants and to minimize property damage. Another thing is protection against extreme weather events. So facades should be designed to withstand extreme weather conditions such as hurricanes, storms, high wind, heavy rainfall, or snow if there's a snow loads. So a facade engineer shall incorporate shall do the structural design of it and reinforce the facade and use appropriate materials to ensure the resilience of the facade against these events. So impact resistant glazing, for example, or wind resistant cladding system and secured connections shall be employed to protect the building envelope and occupants from this kind of severe weather condition. So another thing to consider for the safety and security is the impact resistance of facade. So facade shall be resistant, from the impact from various sources such as flying debris, accidental collisions, or intentional vandalism, for example. So facade engineers should consider the location, the building use, and potential impact of these scenarios to determine the required level of impact resistance, impact resistant glazing. To design this glazing, maybe we need this kind of impact resistant glazing or a reinforced cladding or protective coating to employ and minimize the risk of damages and maintain the structural integrity of the facade. The other thing is you shall also consider the structural stability, of course. We already discussed this structural thing, but for the safety and security, all the loads, including the gravity loads, like I already mentioned earlier, that has to be considered. The wind loads, seismic forces, and other dynamic loads should be considered. So structural analysis and calculation shall be performed to ensure that the facade components, including connections and supports, can safely resist these loads and maintain the structural integrity. So proper structural stability of the facade is very important for the overall safety and performance of the building. Last but not least, for the safety and security is a facade shall be designed to provide a safe and accessible means of entry and exit from the building. The facade engineer should consider the factors such as entrance design, emergency exit, and accessibility requirement to ensure that the facade elements facilitate safe and efficient movements for occupants, including those with disabilities. So therefore, a properly designed and accessible facade should be considered for the overall safety and usability of the building. Last is the sustainability of the facade. As an engineer, we have to design the facade that can reduce the environmental impacts of the building by minimizing the energy consumptions and utilizing renewable resources and enhancing indoor environmental quality. So therefore, because as a facade engineer, the significant role is to promote sustainability and reduce the environmental footprint of the building as much as we can. So therefore, we have to design a facade which is energy efficient by reducing energy consumption, by optimizing a building thermal performance, for example, and incorporates insulated materials and efficient glazing system and shading devices, for example. So therefore, we can reduce the reliance on the mechanical heating and cooling system. So we can also apply a renewable energy system. We can integrate this in the facade. So therefore, we can maybe we can use a solar panel, for example, that can be seamlessly integrated with the facade design to generate clean and sustainable energy. So therefore, a facade engineer shall be consider the orientation, maybe tilt and integration of this system to maximize energy generation and utilization. So by harnessing these renewable resources, a well-designed facade can contribute to the reductions of fossil fuels consumption and promote the use of sustainable energy sources. Last thing about this sustainable is the idea to improve the indoor environmental quality, the air quality inside the building by enhancing by controlling the ventilations and also enhancing the natural lighting and managing the thermal comfort. So the design of facades should optimize the daylight penetration, reducing the needs for artificial lighting and improving the well-being and productivity of the people inside the building. So we have to carefully select the materials, including sustainable and environmentally friendly materials. So therefore, a facade engineer should consider the life cycle impact of the materials, including their extraction. So sustainability is not only about using a solar panel, but sustainability includes the life cycle impact of the materials, including the extraction of materials, manufacturing, transportation of materials, and disposal of materials. So therefore, facade engineers should prioritize the materials with low embedded energy, recycled content, and recyclability. So by selecting sustainable materials, the environmental impact associated with the production and use of facade components can be reduced. Another thing is the water and resource efficiency. So in facade can contribute to water and resource efficiency through rainwater harvesting system. So this is a new innovations in sustainability. Facade system can be used to collect water and other resources like rainwater harvesting system. that can be integrated, gray water recycling, and intelligent irrigation system. I will discuss this in a separate presentation. So to integrate it with the facade design. So facade engineers should consider the collection and utilization of water resources and reducing the strain on water supply and promoting sustainable water management practice. So the integration, another thing with the facade is about the integration with the building system. A facade engineer involves coordinating with integrating various building systems such as HVAC, air conditioning, like that, lighting and renewable energy system, sometimes security. So this process is essential to ensure that the building exterior not only meet the aesthetic and structural requirements, but also to support the optimal functioning of internal system. So because the facade acts as a barrier between the indoor environment and external elements, so it has a big factor to influence the thermal comfort and energy efficiency and natural lighting. So we have to integrate the HVAC system with the facade. Therefore, engineers shall to improve the air quality and to regulate indoor temperature. So facade engineer therefore has to coordinate with the other engineers, architects, mechanical engineers, and environmental science and material science to consider various factors such as thermal insulation, acoustic ventilations, and the overall building performance that affects, maybe consider also the aesthetic of the building. So therefore, an advanced technology and materials like double skin facades and smart glass or smart glazing are often employed to enhance the performance. So we just only mentioned about the smart windows or smart glazing. This is one of the emerging trends, includes the integration of smart technologies, responsive facade, adaptive shading system, and the use of sustainable materials. So smart technologies enables facade to interact with the environmental condition in real time. So this system can adjust lighting, heating, and ventilation based on sensor that monitor temperature, sunlight, and occupancy, thus optimizing energy efficiency and occupants' comfort. So responsive facade, for example, can adapt to the changing environment condition. For instance, a dynamic facade can alter their configuration or properties in response to weather changes, improving thermal regulations and reducing the building's energy consumptions. So this system, this responsive facade might involve movable elements like blinds or materials that change properties such as electrochromatic glass and darken in response to sunlight, what we have on the screen. These are example of electrochromic glass. Adaptive shading system are designed for, this is another kind of system. Adaptive shading system is designed to control the amount of sunlight entering the building to reduce the glare and heat gain. So this system can be automated using a sensor and algorithm to adjust shading devices like louvers, blinds throughout the days, and ensuring the optimal lighting and temperature control, like what we have on the screen, the universal smart windows. So what are the innovations in facade engineering? So this is the most interesting part in our discussion, that the use of sustainable materials is another significant trend. So facade engineers increasingly opt for materials with low environmental impact, such as recycled or recyclable materials, and those with high thermal performance to contribute with the energy savings. So innovations includes bio-based materials, photovoltaic materials integrated into facades, and green walls that provides natural insulations and improve air quality. So these trends collectively contributes to the development of high performance, sustainability, and or sustainable and intelligent building facade. So we can have this transparent PV facade, an opaque PV facade, external integrated devices like shadings, parapets, railings, skylights, semi-transparent roof, for example. So these are kind of sustainable materials that can contribute to improve the thermal performance and reduce the carbon emissions of the building. So in conclusion, facade engineering is a multidisciplinary field. So it's a combination of architecture and engineering. It's a combination of architectural design, engineering principles, and sustainable practices to create a high performance building facade. So the importance of facade engineering lies in its ability to enhance the architectural aesthetic, the visual appeal of the building, the functionality of the facade, and the energy efficiency and the overall sustainability of the building. So therefore, as a facade engineer, let us remember that a well-designed facade is not only to enhance the aesthetic view of the building, but also to contribute to the occupants' comfort, energy efficiency, and environmental sustainability.